today we get to talk about the thing that's going to be the main focus of what we do through the semester, which is predicting the future of various systems under the influence of various interactions with the surroundings. And today we're going to talk about trying to put the whole thing together. We know about updating momentum. We know about updating position. What we're going to talk about today is how you update the position, how you predict the position of something if its momentum is changing, and we'll work through some examples. These are the big ideas so far. The stuff in the box is stuff that you will need to know. Central to the course, that means memorize. Central to the course will not be given on equation sheets in tests, whereas other things like how to calculate this force or that force or what the values of constants are will be given. I've included the speed of light here, although it will be given to you. You should know it because if you ever solve a problem and you find that you calculate the speed of something being greater than 3 times 10 to the 8th meters per second, you should know that you've made a mistake somewhere, and you should check your work. Don't just leave it there. So the definition of average velocity, which some of you stumbled over in the quiz on Wednesday. You're not going to make that mistake again, right? The definition of momentum, gamma times mass times velocity, where gamma is this interesting factor, 1 over the square root of the quantity 1 minus the magnitude of v over c quantity squared. And we've calculated gamma for various speeds, and we have pretty much agreed that as long as the speed is less than 10 to the 8th meters per second, we can usually approximate gamma as 1 without worrying about it. But when it gets that high, we have to start actually really calculating it. And what we did last time, the momentum principle that allows us to predict the future momentum of a system is the sum of its momentum now and the net impulse delivered by the surroundings in the next small time interval. And we really need to take both of these things into account when predicting what's going to happen to a system in the future. All of these equations can be rewritten in various ways. This, of course, can be rewritten in the position update form, where we get R final is R initial plus V average delta T. This can be rewritten, delta P is F net delta T. Different ways of writing them are useful in different situations. So this one reminds us that the direction of the change of momentum in some time interval has to be the same as the direction of the net force applied to it. So all the different ways of writing equations are important.